factoring.
Okay,
It's a
that's what I'm
totally
getting
different.
confused with that.
Yeah. So what are we talking about? Because when we solve equations, yes, quadratic formula is a different story, right?
Right.
Yes, we haven't discussed it. I showed you one example
Okay.
because we had no choice, I believe, or this class or the other class. So no, I don't think I showed it here. No. But when we solve equations, it's a different story, and when we factor, it's a different story. So what are we trying to do? So let's start. I was hoping for an example, so I know what you mean.
I don't have a specific example for that, but I do have a problem that kind of hung me up.
Okay.
1 over x plus 1 over x plus 2 equals 1 over 7.
Good. It's a perfect example, but this is not, it has nothing to do with what you're asking. You're
Right.
asking about polynomials,
Mhm.
and you're asking about trinomials. This is what I thought you did.
Right. When I was doing, because I started to get into the quadratic stuff last
Mhm.
night, and I got to a point where I saw a trinomial that I had seen before, but we were doing a completely different process with this to solve it.
Do you
So I was
have
just-
it? So always write it down so we can.
No, I had it on. I was going through your videos and just going through.
Okay.
I didn't write it down specifically though.
Oh. So you know where it is?
On the homework, I don't know.
Just anywhere. In the video, homework, anywhere.
During the quadratic equation section of the video.
Equations.
Mhm.
Okay, we haven't talked about that yet.
Right.
Okay. So I'll go back to it.
Okay.
Okay, so this is a rational equation. Let me ask you this. How many of you reworked on the problems we did in class that are rational equations? Right. Okay, perfect. If you don't, then you're going to fall behind. So you're going to get into difficulty later. Good. So what do I do?
So you have to move the 1 over 7.
Yeah, I wouldn't say you have to. I'm sorry. This is what I recommend. 1 over x plus 1 over x plus 2 minus 1 over 7 equals 0, mandatory. If you use this method, you have to have 0 on the right-hand side. Good. Next.
Common denominator.
Restrictions.
Okay.
If I find the least common denominator, I may forget to write restrictions. So the second step should be restrictions. Or first step from the very beginning, state restrictions. Okay, I'm ready. What do we have to write here?
0
Yes?
and -2.
Excellent. Now the least common denominator. How many different factors we see here?
3.
Yes, 7x plus 2. We had a similar problem, I thought. Maybe I forgot.
So because the x plus 2 is its own term, x is its own term and 7 is its own term?
So
'Cause it's-
can you factor x?
No.
No. Can you factor 7? No. Can you factor x plus 2? So there are 3 different factors. They have nothing in common. It's like 1/2 plus 1/3 plus 1 over 7. 2, 3, and 7 have anything in common? No. So the least common denominator must be 42. In the same way, x plus 2 and 7 have nothing in common. If I could have factored this somehow, I would have.
Right.
Absolutely, before finding the LCD. But I can't factor any of those. So now the adjustments for the top.
So you just
For the first one,
gotta rewrite 7x plus.
14. Very good. Awesome. For x plus 2,
So why is that 14? Maybe I'm just going too fast. 7. Okay, I see.
I want to make it my life easier, so I will multiply over there so that I don't have to do it later.
Okay. Yeah, see, I was adding that extra step in. So,
That's fine.
yeah.
It's not a mistake. Okay, for the next one.
So next,
Yes. For the last one.
you just gotta do
Yes. Anyone? One. So the denominator is 7. If I put 1 here, it means that the least common denominator is 7.
Right.
Is the least common denominator 7? So
So it's going to be x squared
x squared.
plus 2.
But if you
Or-
distribute x to x, you cannot forget to, yes.
Okay.
Is this clear? Say it again. Okay, so the least common,
Can you go like through each individual step of how you get those numbers up top? Because like how you got the
yeah, this is exactly, give me 1 second. So if this denominator is x, and the least common denominator is 7x times x plus 2, what is here but not here?
Oh, okay.
So 7 is not here, x plus 2 is not here. It means that I multiplied x by 7 and by x plus 2 to get this quantity. I have to do the same thing to the top.
okay, so it's just whatever.
So 7x plus 14. So if you go home after class and redo the problems we do in class, you're gonna make a leap forward, not a step forward. But if you wait from Monday till Wednesday to redo this, it's gonna go away because it's not something we think in terms of, every second of our life.
So you're saying this is something that you need to just keep doing consistently?
Exactly. When I learned this, that's what I did. I had my grandma behind me. The wood spoon. There is no other way. If you don't do it every day from Monday till Wednesday, you forget. You looked at this and say, oh, I've never seen this before. But if you turn a few pages back, you're going to see it. It was done last Monday. That's how it is. That's how the brain works. We have to, if we want to learn something anew, it's the only way. I do the same thing. When I learn something new, it takes, and for me, it takes 10 times more time than it takes for you because you have a fresh brain. I no longer have a fresh brain. For me, it takes even longer than it takes you to learn something new. Okay, so x plus 2 is here, 7 and x are not. 7 is here, and x plus 2 are not. Is this okay? Perfect. So then 1 times 7x plus 14, 1 times 7x, and negative 1 distributed to these two terms, negative x squared minus 2x. So we've seen this before, right? Everything, no part of this is new. But it wasn't super clear. And now it is clear, so go home and do 10 more problems. And then say on the side somewhere in the notebook, I really mastered how to solve rational equations. And it's done. Okay, so of course we combine like terms. So then we have negative x squared, and this is 14 minus 2, which is positive 12x, and then plus 14. 7x, x plus 2 equals 0. If you remember last time we discussed and we said there are two options here, at least two options. You may find a third option, and I'm fine with it. A fraction is 0 when?
Points over 1.
Okay, let's go back to our notes from last time. And when we said the fraction is 0 when? These are new concepts. So all these new concepts, I would put them in a little notebook and say a fraction is 0 only when the numerator is 0. If I don't write this down and read it, several times, it will go away. So fraction is 0 when the numerator is 0. It's quadratic. I refuse to solve a quadratic equation with a negative leading coefficient. So x squared minus 12x minus 14 equals 0. Any questions? Any questions, ladies? Any questions? Hello? Hello, ladies, any questions?
So did you just take the negative 1 out?
No. I multiplied, and in any equation, I'm allowed to multiply both sides by negative 1. That will not change the solution. I cannot do that in an expression. If you say factor this, I won't be able to get rid of the negative 1. I am able to factor it out, but it will stay there as a factor. But in the equation, I'm allowed to divide both sides by negative 1, and the solution at the end will not change. That's why I put that in our strategy. Always take the negative 1 out. If it's something you have to factor, the factor has to stay. But if it's an equation, I can always divide by negative 1. I'm not going to change the solutions. Okay, so did we copy the problem correctly from the very beginning? You're sure that that was correct? I mean, we don't have to get an integer as the answer. Anything can happen. So you're sure that this is correct?
Yeah.
Okay, so we had x 7x. Yes, I'm just checking because we have to use the quadratic formula here. So I'm just checking one more time. It was 7x plus 14 correct, and this was 7x correct, and this was x squared plus 2x correct, minus x squared minus 2x, and this is indeed 14 minus 2, which is 12, and that's 14. I copied everything correctly, so now we have to use the quadratic formula. So let me refresh your memory on the quadratic formula. Only when the equation is presented in this format, you can identify these coefficients. Of course, you have to take them with the sign in front, whatever that sign is. However, I strongly recommend do not solve a quadratic equation if it has a negative leading coefficient before you multiply both sides by negative 1. Because if you have this number negative, then it will be in the denominator. It may create some difficulties. I'm not saying it's a must, it's a recommendation. So this is negative b plus or minus the square root b squared minus 4ac over 2a. And yes, you have to remember this. Any questions so far? Any questions on the process so far? Okay, so then negative b squared minus 4ac times a, which is 1, times negative 14 divided by 2 times a, which is 2. So let's see what we get. I also wanted to show you the quadratic formula, but I also want to show you how to put this in the graphing calculator. So any questions? Ladies, yes. Any questions? Hello, hello, hello. Any questions? Please ask.
She just asked me one question right now.
Okay, please ask because other students may have the same question on their mind, and you're helping everyone. Go ahead, please. Any question?
Okay, well, I'm way behind where you are right now.
Okay, so where are you?
Like, yeah, the combining part.
Combining like terms?
Yeah.
So there is a negative x squared, and 7 plus 7 is 14, minus 2 is 12. And I copied the 14. Is that okay? Yes? So 7 plus 7 is 14. Minus 2 is 12. When we combine like terms, we also put them in descending order. So we have to start with negative x squared, and then we have 3 terms that are like terms, and we get 12x, and then we copy 14. Yes, please.
So I know if there's no number there, it's just a 1, right?
Yes.
But so how come it's not 11 instead of 12?
You mean this one?
Yeah.
7 plus 7 is 14. 14 minus 2.
You don't minus the 1 from the x.
But this is x squared. I put it in front already. So x squared has nothing to do with x. These are like terms. So 7 plus 7 minus 2 is 12. And then we copy the 14. Is this better? Yes, everyone? Okay. Is everything else okay? Is this okay now, the negative x squared plus 12x plus 14?
Can you show how you do that stuff again?
Which one?
The one, I got like the division part of it. Like,
From here?
yeah, yes.
Okay, last time we had two options. Option number 1, you put over 1 and you cross multiply. Option number 2, you say a fraction is 0 only when the numerator is 0 and you set it equal to 0. I'm just checking my memory because maybe I didn't say this. I don't want to. Okay, two options. So this was in the lecture from last time. So it's your obligation to redo these notes several times till you commit this to memory so we can make progress. A fraction is 0 only when the numerator is 0. That's one possibility. The second possibility is you can change it into a proportion and cross multiply. So you have the denominator times 0 in our case, and the numerator times 1 in our case. And in both cases, we get the same thing. Is this okay? Please redo the notes diligently. Yes?
So if we left the 1/7 where it was,
Yes?
all the way down,
Yes?
we do the portion.
Yes,
Okay.
you can. But then, it's a perfect question. But then if you do that, nothing wrong. I'm not against it. But then you're not going to get a 0. You'll still have to move terms around. You'll still have to multiply. So I'm not saying it's wrong. I'm saying it's perfect. If you want to use that method, I completely agree with it. But remember, at the very end, you're not going to get the 0.
Right.
So if you want to get the 0, then you move everything to one side and then you cross multiply, or you say a fraction is 0, only the numerator is 0, and I'm done. I don't have to multiply. It's an additional step to move everything to one side, and you have an additional step at the end to cross multiply. So they cancel out. Same thing. Very good. Good. Going back. So no, actually, I was still here, right? With this. So let's put in the graphing calculator. When we put a situation like this in the graphing calculator, we must put parentheses around the top and parentheses around the denominator. So this is fine. But for the graphing calculator, I have to have parentheses around the entire numerator and parentheses under the square root. So let's do that. So the left parenthesis, 12 plus the square root. If you have questions, I would rather ask, please ask out loud. 12 squared. The minus with the minus will change into a plus. It's a product, so I'm going to multiply. I'm going to put plus 4 times 14. I will close the parenthesis under the square root. I will go outside of the square root and put a parenthesis, and then divide by 2. If the denominator is a product, for example, I will put the denominator separately in parentheses. Otherwise, you will have to divide by each portion, so it's slightly more difficult. So this is one solution. In order to get the other solution, what I recommend is go to second and entry. It copies everything you've typed in. And then you can, for you, it would be easier than with the software. And just go back here and change or override plus into a minus. If you want to type it up again, it's fine. There is nothing wrong with it. But it will save you some time. In my case, it takes much longer to move that cursor. Yeah, of course, and it always goes all the way, and I have to bring it back. Okay, minus. So these are the solutions. Now, if my math lab is asking you to determine an exact solution, Then I'm just going to multiply or square 12 and plus 4 times 14. And I get 200, and I will simplify that. So here are possible solutions depending on what they are asking you to write. One solution is 13.07. The other solution is negative 1.07. And the exact, if they want exact, the exact solution would be 12 plus or minus the square root of 200 divided by 2. And that is not done because we have to simplify it. And 200 is 10 times 2, so then x equals 12 plus or minus 10, 100 times 2, the square root of 2 divided by 2. If you simplify here or you simplify here, it will be terribly wrong. You can separate it into two fractions, this fraction and this fraction. So x equals 6 plus or minus 5, the square root of 2. So these are the approximate solutions. But the 6 plus or minus 5, the square root of 2 is, yes?
For the purposes of like tests, quizzes, do you want us, if we left it with not simplified?
If the problem is asking you to present an exact number, you have to show the exact. If it's asking you to approximate, then you will approximate.
Okay.
Now, if it's a word problem and I have to give you an answer how much money I have in my pocket, I'm not going to tell you that I have 6 plus 5, the square root of 2.
Right.
I'm going to say I have $13.07. Sorry, Karen?
I think I just missed it. Where did I think it's a 200 come from underneath the?
12 squared plus 4 times 12, 14. Unless I made an error.
No, I just,
You
I
made
think
it
I
right?
missed it. I was writing and I just missed
Yeah,
where you
12
were
squared,
from.
I just calculated what's under the square root. So under the square root, 12 squared plus 4 times 14, I got 200. If that is wrong, then let me know.
That's a plus sign.
Two minuses will give us a plus.
Okay, because you have to do that. Okay. Got it. Thank you.
Perfect. Good. Next question. Does this make sense? Yes, please. Yeah, so now if you have here multiplication or something, then you will have to put this in parentheses as well. But if you only have one number, that's fine. Okay, next question. Anything else? Yes, please.
So, I think I'm just trying to figure out what lesson, should we be on as of coming into class today? Like, how many should we have completed?
So if you're,
Like, which one should we
Yeah.
have completed,
so let's go back.
basically?
So let's go back.
I'm just trying to figure out, where we're at,
Right.
we're
Okay,
supposed
perfect.
to be.
So here it is.
Yes.
So yes.
Okay, thanks.
Okay. So every time when we
Where do you want us? What's a good spot that you want
okay,
us? Like?
so I wanted you to finish the factoring,
Okay.
and I wanted you to finish the 1.1, 1.2, and we are right now on 1.5.
Okay.
These are rational equations.
So we'll go into the weekend doing
Yes.
1.5,
1.6. Yes.
and that's it.
And I would like you to, once you say, I understood the material, I checked myself with the recommended problems and with the answer in the back,
Uh-huh.
then you can attempt your homework. I don't expect you to
Okay.
finish all this homework from the beginning till 1.6 till Monday.
Okay.
But I expect you to be somewhere halfway through.
Okay. That's what I was.
Each
struck
section, not halfway through 1.1.
Right.
Okay?
So the homework will basically come with the videos.
The homework is in my math lab.
Yeah. But it'll be what we learned through the videos.
Of course.
Okay.
Of course. If you encounter a problem in my math lab,
Then that's what's covered.
but you have to do the studying first.
Right.
Because otherwise you'll have to go back to your notes every 3 seconds, and
Yeah.
that's not studying.
Okay.
Right.
Thank you.
And you may encounter problems that you don't see in the video. Please bring them to class so we can all work on them together. Okay. So
Thank you.
thank you. So one more time, here's what I would like to, so this is what we covered, linear equations, last time and today. And I would like to talk about these 4 methods of solving quadratic equations. Has anyone gotten that far? One person, two people. Okay, I would like to review this so you have an idea when you get to it. So we can finish up 1.5, and that's the end of 1.5. And then 1.6 has more types of equations. So let's go back to quadratic equations.
I have a question.
Please. Yes, any.
1.5 was taking the square root a part of that, or is that the next section?
Yes, and it's 1.5. It's at the end of 1.5. So let me talk about that. Let me talk about that, and then I'll answer your questions, or I can answer your question and then talk about it. It's up to you.
I mean, it's just like there was a problem in the video, like
Yes.
I just feel like for me, I need like every single step so I know exactly what's happening. And so like one of the problems in the video, it was the square root of x minus 3 squared. X minus 3 squared equals 36, and we were supposed to take the square root, and then something happened, and then all of a sudden we had x equals 3 plus or minus 6, and like the solutions were 9 and -3, and I have no idea where that came from.
Okay. So that was one of the methods that I was going to review with you right now. So let's start with this one. And then I'll summarize them again after we finish this problem. Perfect example. So when we have a quantity that has x in it and it's squared, and a number on the right-hand side, were you able to watch the video on this or just look at the notes?
Well, yeah, like the video was like your notes too, so I was like going along with the video.
Excellent. Excellent. That's the right way to do it. Perfect. So the idea is, so taking square roots. When will I take square roots to solve an equation? When I have something with x squared and a number, k. And then I will take square roots from both sides. The correct answer, if you remember radicals, the correct answer on the left-hand side is the absolute value of x, not x, equals the square root of k. But this equation, does anyone remember solving absolute value equations? Exactly. Awesome. Very good. So one option is the square root of k, and the other option is negative the square root of k. This is the procedure we will apply, and this is what I presented there before looking at examples. Say it again.
I'm confused because, like, you were working on this problem, but it looks like you're working on another problem.
This is the theory. I have to present the theory before I show any example. So I can explain this, I have to show the theory first. The concept of taking square roots.
She's showing you how she would solve that problem, how she's gonna solve that problem. Like the formula she's gonna use to solve that problem, basically.
So I have to show what's behind this situation. This is a case, but this is what will work for every case. This is the method that we are going to use every time we try to solve in that way. So the method is called taking square roots. So every time we have x or an expression with x squared and a number on the other side, we will take square roots. We'll apply the square root to both sides. The left-hand side becomes the absolute value. The right-hand side is simply the square root of k, whatever that is. And this equation has two possibilities, two solutions. X inside can be the square root of k or the negative square root of k. This is the theory. But what I'm going to show you will be much easier than this. But this is what the method we are going to apply. So we see x minus 3, everything squared, equals a number. We realize that this is typical for taking square roots. So we will take the square root from the left, and we'll take the square root from the right, exactly how we did it here. The left-hand side, instead of writing this step, I'm crossing it out not because it's wrong. I'm crossing it out because we normally go directly from solving the equation to the solution. We do not present the intermediate step, which in my opinion is a mistake. Because when I'm going to write plus or minus on the other side, some of you may say, oh, the square root of 36 is plus or minus 6. No, it's not. The plus and the minus come from the absolute value from this side. So that's why I think it's wrong that we skip this step. But that's what we do. Not me, in every book. Okay, so then the left-hand side will be x minus 3. Yes, Kayla?
So the 2 and the square root cancel each other out, and that's how you get x minus 3, right?
Because this power is basically any square root is power 1/2, and this is power 2, and 1/2 times 2 will be 1.
Yep.
Yeah. So then the answer will be 3 plus or minus 6, and from here we separate them. And we get x equals 9, and x equals negative 3. Is this okay now?
What you say one more time?
Which part?
Like how you got the 9 and the negative 3.
So when I move 3 to the other side, it becomes positive. It was negative here, will become positive on the other side. And I just perform the operations. 3 plus 6 is 9. 3 minus 6 is negative 3. Yes, these are the answers. Correct. Kayla?
So you could go one extra step before you.
Yeah.
Right here?
Yeah, right here, and you could do x
Yeah.
minus 3 equals 6, x minus 3 equals negative 6. Right?
You can. We don't need to do that normally, but you can. It's
But you
not
can
wrong.
do that, and
Sure.
you're gonna get the same answer.
Yeah, of
just so
course.
you write out the steps.
Of
But
course.
that's
I thought you were talking about the absolute value.
No, that's what you did in your head, though, basically.
Yeah.
No, I didn't. I just moved. Here you want to write 3 minus 6 and 3 minus
I'm
6.
talking about the blue where it says x minus 3 equals plus or minus 6.
Right.
You could write out two separate, like you could write x minus 3 equals negative 6.
Right, but we solve for x, so you can move 3 first and then separate it here. It's up to you.
I think when you skip what you think are little steps, it confuses a lot of people because you're used to doing it, but when you skip the little steps, it kind of confuses people.
Yeah, so all you stop me and I'll explain what it is. No problem.
See, but like in the video, you know, like I can't stop you in the video and be like, hey, what's that? So then like trying to move on to finish like the video out, it's like confusing because like it seems.
But that's why we discuss all these things in class. That's why you
I
bring.
don't- For me, like watching these videos first and then like coming here is like really confusing to me. I feel like the videos should be like a refresh, like if we're at home and we are confused about something, to go back and be like, okay, oh, this is what she did. After hearing you like already explain what's in person first, so like the videos to me are very confusing. It's not for me. It's not helping to watch the videos and then come here.
I don't have any problem making a change. I mean, if you agree with that, I'll present and then you go home and study. But if you do not see them ahead of time, you will be bored.
I'm not bored.
Okay, then.
Like either way I come to class, I still have no idea what's going on. Like whether I watch the video or not, I come here and it still feels like the first time he's seeing it because like she said, like little steps they do make like a really big difference. Cause like now you just said that, I'm like, oh duh, like that makes perfect sense of how we just got the 9 and the negative 3. But like without those little pieces, it makes it very hard to understand in the videos. Like you do kind of just like skip those little things, and it makes it difficult to stay like keep going.
What if you just watch the videos and you just write down what it's not clear and we start with that?
But isn't it kind of counterproductive if we don't understand something, like past that point, if we don't understand something prior, then how we gonna we don't understand the rest of
can't
it.
keep going
Like
in the
if the hours,
they-
I mean the videos like an hour long or so, and if we don't understand something that's 15 minutes in, then how are we gonna understand anything else for the rest of the 45 minutes the video's playing? I'd rather be explained it first and be able to ask my questions in person and then go home and study the video as like a refresher.
I don't have any problem. As I mentioned from the very beginning, I said I let you decide.
Because like I feel like we're coming in and we're already sprinting and we haven't even gone for a job yet.
I don't have any problem with making the change and going back to just presenting what I have to present.
Yeah, 'cause I'm watching these videos, but
I don't have a problem.
I think with some
If you think that works best for you,
I think sometimes the videos like all over the place. So you trying to like grasp this, and then it's like it's another step, and then it's like what I missed there, and this, that, and the third. So I think being more visual sometimes will help more people because then when they see the video, it's like, oh, okay, that's what it is, and stuff like that.
if you remember when we discussed the first time last Wednesday, I said the following Wednesday we're going to sit down and talk about it and see how it works. If it doesn't work, we'll go to something else. I just want your participation. I just don't want to see cell phones on the table and not paying attention. That's all. So you decide. Whatever works for you, it works for me.
I think the video should be reviewed as to what we first learned in class first.
Excellent. So our next step is to solve quadratic equations. Solve quadratic equations. And there are 4 methods. First method we already discussed over and over, factoring. I consider this done. And if you have any questions, do we have any questions on factoring? So factoring is completely done with everything, binomials, trinomials, polynomials, sum of cubes, difference of cubes, all of that, right? So that is done. Everyone agrees with that? Yes? Okay, so the next method is taking square roots. So let's look at another example. Let's say x minus 1 or x plus 1 squared equals negative 16. So this is another typical example in which we have to take square roots from both sides. So we are going to do that. The left-hand side will be x plus 1. The right-hand side this time is not a real number. So the square root of negative 16 will be split into, if you remember, the square root of negative 1 and the square root of 16. Where do we remember what the square root of negative 1 is?
I.
Perfect. And the square root of 16 will be 4. So then the answer will be plus or minus 4i. And as a final answer, we move 1 to the other side. That was the reason why I recommended you do not split the equation till the end, because you may encounter something like this, which is a different story, and you should not split it because here you cannot simplify.
Wait, explain the I again.
It's the square root of negative 1.
Okay.
So what about when the negative is outside of the square root?
It's a different story. Perfect question. So negative the square root of 4 is indeed negative 2. But the square root of 4 is only 2. So this one is called the positive square root. And this one is called the negative square root.
Negative is outside of the square
That
root.
is allowed.
You don't have to use the
You're multiplying. No. This is multiply. This is negative 1 multiplied by the square root of 4. You have to perform this operation first, which gives you 2, and you multiply by negative 1, and you get negative 2.
Okay, gotcha.
Because the square root is a power. The square root is power 1/2. Yes, please.
So we have to add the I on homework, like when it's an answer?
If you get the square root of a negative number, you have to have I in it. Yes.
And then if the 16 was positive, you won't ask you the I's.
I already took the I out. The square root of, so negative 16 is negative 1 times 16. I don't have another negative 1 in there.
I'll come with the first one.
So the negative 16 is not negative 16. Negative 16 is negative 1 times 16. The square root of negative 16 will be the square root of negative 1 times 16. And you split it now into the square root of negative 1 times the square root of 16. Is that what you're asking?
Yeah.
So you cannot have another negative connected to 16. This was the only negative that is connected to 16, the negative 1. Negative numbers were obtained by multiplying positive numbers by negative 1. Did I answer your question? Is that good enough?
Yeah, that's fine.
Good. Other questions here? So that was the second method. Moving on to the third, we need more examples. Are we okay with taking square roots? Yes. Would you like to choose one? Do you have your book? Do you have your my math lab, or do you want me to choose another, or you want me to choose another?
Yeah.
Okay. So let's say 2.
Go along with like the negative outside instead of inside the square root.
With a negative outside of
Yeah,
the
like-
square root.
Yeah, because I want to have it inside with the I.
But that's not going to happen. because you will have to take the square root. You're not going to take the square root and put a negative in front. So that was just a situation that was asked. What about this situation? It has nothing to do with our problem. I will not encounter something like this. If it's a negative number I saw outside, I cannot just take the square root from a positive number and leave the negative outside. When I take it's actually a very good question. When I take the square root from the left, I have to take the square root from the right, not portions of the right. I cannot just say, oh, I don't like that negative. I'm just going to put the square root on top of 16. I can't do that. So that's why this situation will never be a case, a possible encounter here. So I can't find something like this for you. That has nothing to do with what we were discussing. It was just a question on what happens if there is a negative outside of a fraction for whatever reason. But it has nothing to do, it's not connected to this problem. Is that okay? Perfect. Okay, so here's another problem. I'm sorry?
Is that a minus?
Of course, yes. So what do we do? Any suggestions for this problem?
Move the 4 over.
Of course. I did. What do I do next?
Distribute the two.
I can never distribute because it's a power. How can I distribute?
You divide both sides.
Thank you.
That's what I meant.
I know you did. And only now I can do this. And as we know, the two options are very clear. Plus or minus the square root of 7 and move 3. So please do not separate them from the beginning, separate them at the end. But it's not wrong. We just don't separate them at the beginning. So are we okay then with taking square roots? So this was a situation in which 2 other steps were required. Yes, please.
How did you get 7?
I'm sorry?
How did you get 7?
I divided this side by 2 and I divided this side by 2. So we said we were dividing both sides by 2 to eliminate the 2 in front. That's the only option. Very good question. Anything else? Okay. So are we in the clear then with taking square roots? Yes? Everyone? Perfect. Here's the third method. The third method is not, in my opinion, something that we should study or is really helpful in solving quadratic equations, but we need it for something else at the end of chapter 2. So that's why we study it. It's called completing the square. So completing the square alone will not solve a quadratic equation. I have to give it a heads up. It will not solve a quadratic equation. We have to go back and take square roots. But let's see what's behind the method. What does it mean? What am I trying to do and why? Any polynomial, quadratic polynomial, like this, any leading coefficient, any middle coefficient, any free term, can be written as, with a outside, x minus a number squared plus another number. These are different, or they could be the same. Everything. Any quadratic polynomial can be written as a perfect square with a number in front or not. Less important. So, like a perfect square plus a number or minus a number. So here is an example. Let's say x squared minus 2x plus 4. I claim that I can write this as a perfect square plus a number. But that's my claim, but I haven't proved this. I have not shown you why I claim this and how I get from here. Last week we looked at a plus b, everything squared, and we looked at a minus b, everything squared. And I'm expecting everyone to shout out what to write here. I'm ready. Yes? Say it again.
Plus. plus 2ab
B plus AB.
Thank you.
plus b squared.
Excellent. And the other one?
A squared minus 2ab minus b squared.
Never?
That's the minus
Never?
one.
Plus
Yes.
b squared.
The only difference is here. Never on the last term. The last term is always positive. Excellent. Great job. Okay, so then, looking at this term and this term, what do you think I should have as the third term for a perfect square? X squared minus 2x plus what is a perfect square? And here's how we determine that number. We identify the middle coefficient. Number one, identify middle coefficient. Can anyone give us the middle coefficient? Assuming it's in descending order, it has to be.
-2.
Excellent. Step number 2, divide it by 2. Why divide by 2? Because of this 2. That's why I need to divide by 2. So please divide -2 by 2 and tell me what you get.
-1.
Excellent. In step 3, square -1. So when you square -1, you get,
1.
that's it. This is the number we have to have next to x squared minus 2x. Okay? So if that's the case, I'm going to write with your permission this. And now this piece will be replaced by, as I promised, a perfect square plus a number. But now please give me the perfect square that replaces these 3 terms in here. So when I square this, I get these 3 terms. That's the reason why we studied those 2 or 3 special products the first day of classes. Yes? Say it again.
So did the 3 come from because we took the 1 from the 4?
1 plus 3 still has to be 4. I can't change the problem.
Okay, so those 2 numbers have to equal the original number?
I can change the problem, yes. Yes,
Okay,
of course.
So that 4 had been a 5, it just would have been 1 plus 4. Okay.
So what perfect square binomial will be this?
-1.
That's it, indeed. X minus 1 everything squared, as we know from last week and from a long time ago, is the first term squared minus 2 times the first times the second plus the second term squared. Now, how do we apply this method in solving equations? So I showed you the method. This is what we need to do. It has these 3 steps, basically 4 for equations, because I have to add 1 to both sides. So we identify the middle coefficient, we divide it by 2, we square that number, and then we add 1, in this case, to both sides. This was not an equation. I just wanted to show you the method so you know where it's coming from. So now we are going to apply this method to equations. So let's say x squared plus 6x plus 12 or 10 equals 50. I just made it up. Okay, we're asked to solve for x. For x using completing the square. Okay. Perfect. So my first step is to clean it up. One option is just move 10 to the other side. I don't need it. I don't care for it. X squared plus 6x equals 40. When we move one term from one side to the other, you don't have to change your style. Just say write minus 10 minus 10 if that's what you want to do. But I prefer, and everyone should know by now, that when we move one term from one side to the other, it only changes its sign, but you don't have to change your style at all. Okay, perfect. Middle coefficient, please. Excellent. No, a middle
6.
coefficient, 6. Perfect. Divided by 2.
3.
Square that number, please.
9.
That's it. We add 9 to both sides. Oops. 40 plus 9. Please complete the square on the left-hand side. Give me the perfect square as we discussed last time, on last Wednesday, actually.
X minus 3.
Excellent. Plus.
Or plus 3.
Yes, excellent. Perfect. Perfect. So we managed to, yes, both of you.
The 2 of the dividing by 2, the middle coefficient.
It comes from the formula a squared plus 2ab plus b squared. That's why we need to divide by 2, from that 2, in order to get the second term. So by comparison, so we have 6x and we have 2ab. I know one of them. I divide by 2 to find the other. I have this one.
Oh,
I divide by 2 this expression. I divide by 2. I have this to determine the other one.
okay.
Yes, please. You had a question.
How did we get 9?
I identified the middle coefficient, 6. I divided it by 2. I got 3. I squared 3. I got 9. So these are the steps. We presented the steps in the method. Identify the middle coefficient, divide it by 2, and square the number. These are the steps in the method of completing the square. So in this case, it was 6. We divided by 2. We got 3. We squared 3 to get 9. So that's what we have to add. And we have to add to both sides. Otherwise, we change the problem. Other questions so far?
So then how did you know it's X plus 3 squared?
Because we discussed last Wednesday that x plus 3 squared is x squared plus 6x plus 9 from this special product. And because we factored, we did all the factoring already. That's why I was asking at the beginning, are we sure that the factoring is done? Yeah. And that was the first step, because otherwise we can make progress. Now, this is the setup, perfect for which method? Excellent, well done. So we have to take the square root as we did. So what you notice here is what I said a few minutes ago. Completing the square will not solve an equation. We still have to use the method from before. So then why are we doing this? In preparation for something that follows later in chapter 2. It's really, if you ask me, and this is extremely important, I'm given a quadratic equation. Which method do I use? Right? I know 4, including the quadratic formula, right? I know factoring, I know taking square roots, I know completing the square, and I know quadratic formula. How do I know which one? Assuming they don't indicate which one. Okay? So how do I know which of these methods to apply? Here's how I know. My first thought is taking square roots, because it's a very specific type of problem. It has to have x inside the parentheses and square and the number on the other side. If there is no 5x in there, then I know taking square roots is my first thought, first method. Factoring, not always works. So it depends. If it takes me more than 20 seconds, 30 seconds to factor, forget it. I'll use the quadratic formula. When will I use completing the square? Never. Unless I'm forced to. And you will be forced to, at least on one problem, to use the completing the square. But I will never, ever use complete the square on a quadratic equation. I should use only 3. If it's convenient to take the square roots right away, if it's factorable in 30 seconds, if not, quadratic formula. Does it make sense? So in this case, I have x plus 3 equals plus or minus 7. And do not separate just yet. And now separate, but it's up to you. I accept anything that works for you.